Morning, class. It's Sir Capistrana again, and welcome back to another discussion here in organic chemistry or our Chem 21. And for today, we'll be continuing our discussions regarding the organic derivatives of water, and to be specific, we'll be talking about phenols. By phenols, from the Greek word pheno, which means light bringer or the bringer of light. Uh, Phenol is actually just another aromatic hydrocarbon, or to be specific, it is also called hydrobenzene, wherein hydrobenzene is just our benzene ring with hydroxyl group. And in that, phenols actually contains hydroxyl group bonded to an sp3 hybridized carbon that is part of an aromatic ring. And to be specific, kapag sinabi natin phenol, dapat yung ating hydroxyl or yung ating OH molecule or OH is actually attached to the ring itself. So kapag naka-encounter tayo ng ilang benzene, merong OH pero hindi mismo directly naka-connect yung OH dun sa ating benzene ring, it is not actually phenol. And in that, let's go into the nomenclature of phenol. So for the nomenclature of phenol and other aromatic compounds, I have here different examples of aromatic hydrocarbons. And one example of that aromatic hydrocarbon is actually our phenol. And as you may notice here, our phenol is actually just one of the benzene compounds, or what we call aromatic compounds. And to be specific, we have here different common names slash IUPAC names of aromatic compounds. So we have here benzonitrile, or benzene ring with a cyano atom attached into it, or that has a cyano substitute. We have here our phenol, our toluene, benzoic acid, benzaldehyde, acetophenone. We also have here styrene, anisole, aniline, benzosulfonic acid. We also have here an orthoxylene, and we have here a mesitylene. As you may notice here, if you look into some of the names of these aromatic hydrocarbons, phenol is just, ay, nag-iisa lang yung phenol na merong name na phen. Okay? So, in here, as you may notice, class, if we have here a benzene ring that has an attached OH, automatically, the name of those aromatic hydrocarbons will actually bear that pen name. And for the other aromatic hydrocarbons, its base name or yung pinakang parent chain na pinukuhanan natin is laging merong benzo. Okay? And actually, kapag isulat natin yung yung name nitong toluene, toluene is just a common name. It is actually methyl benzene. Okay? And if you continue on uh, with that notion, as you can see here, again, we have the benz, we have the benza, and this is actually just another benzene ring wherein this is actually what we call benzyl ethanone. Okay, this is one benzene ethanone, and we have here the styrene. This is actually again a benzene, another benzene, and so on and so forth. And as you can see here, benzene. So, medyo special yung pwede nating i-treat actually yung special yung ating mga phenols because in naming them, it actually bears the pen name, where is from the word phenyl, where, na ang ibig sabihin na yung benzene ring lang din. But Specifically, it is always uh, wise to use phenol for those benzene ring bearing our hydroxyl group. And I have here some other examples for the nomenclature of phenols. So we have here this compounds. So as you can see here, pwedeng dalawa lang yung maging candidate natin ng phenol dito. But actually, the only phenol compound we have here is this one, our 2-chloro uh, phenol. As you may see here, hindi na phenol yung iba dito kasi we don't have an OH group that is attached to our ring itself. And as you may notice here, we have here this one. We have an OH here. We have a hydroxyl compound here. But this hydroxyl is not directly bonded to our ring, meaning this is not a phenol. This is actually an alcohol, and this is our benz benzyl alcohol methanol, and we have here our 1,2-dimethyl benzene, and we have here 1,4-dichlorobenzene. So isulat lang natin na this will be sinulat yung mga pangalan nila. So, pangalanan na lang natin. So, this will be our dimethyl. This will be 1,2-dimethyl benzene. Right? And we have here 1,4-dichlorobenzene. And as we can see here, we actually have here benzyl methanol. Okay? So, as you can see here, for the nomenclature of phenol, kapag merong OH na attached dun sa benzene ring natin, it will be called phenol. But, or otherwise, it is usually a benzene. Okay? So hopefully, magiging clear yung distinction natin when we are dealing with phenols. So, actually, kung babalikan nyo yung mga ano natin dati, yung activity natin regarding functional groups wherein I asked you to identify the functional groups that is present in serotonin, ano yung ginamit natin, adenosine or yung sleep ano natin hormone and estrogen. Some of them actually, or actually two of them has phenols, wherein we have there an aromatic ring and we have an OH group that is attached to that aromatic ring, meaning to say its functional group is phenol, not alcohol. Okay? So in that, let's move on into the physical properties of phenols. So for phenols, since phenol is bearing an OH or a hydroxyl group that is attached into it, we may expect that we also have our H bonding here, just like our alcohol. Phenols uh, are capable of H bonding with its molecule of its own kind. So H bonding or hydrogen bonding with uh, its own kind. And how about sa water? Pwede tayong magkaroon ng ng hydrogen bonding sa water. But medyo lang, slightly soluble lang ang ating phenol sa water. And for large phenols, yung mga madami ng substituents, may mas malaki yung tendency na maging non-polar siya due to the benzene ring. So, basically, due to H bonding, we can expect that we have high boiling points. And as we have stated earlier, we phenols are actually slightly soluble or at some cases insoluble in water. And bakit siya insoluble or slightly insoluble sa water? Gawa ng ating large na benzene ring. And so, because this large benzene ring is actually non-polar, yung side na to, and ang polar na side lang natin ay yung OH, and in comparison with space that is occupied by the benzene ring and the hydroxyl, mas mananaig yung ating non-polar side or non-polar benzene ring. So, in that, let's move on to the reactions of phenols. So for the reaction of phenols, we will actually looking into just three reaction mechanisms, but those three are actually just the general types of reaction that exist in phenols. So we will be talking about formation of phenoxide ions, wherein we will consider the acidity of phenols. And we will also look into EAS or what we call electrophilic aromatic substitution and also oxidation. And in that, our first reaction mechanism or reactions of phenols that may exist on our OH group in the carbons of the aromatic group is our phenoxide ion. So, in existence of OH ions, kapag nagdagdag tayo ng reagent na OH, we will actually be producing what we call phenoxide ions. So, what is so special about phenoxide ion? Sa phenoxide ion, due to the presence of that OH, we will experience elimination reaction of that hydrogen. Meaning to say, we will have a phenol here or an organic compound that has an oxygen bearing a negative charge. So, in that, we will have this molecule. So this actually is what we call the phenoxide ion. And that phenoxide ion can actually exist in different forms due to the movement of the charges in our phenoxide, the just like our discussions regarding resonance structures of benzaldehyde and resonance structures of aniline, wherein due to the stability of the benzene ring, we may expect that that negative charge may move around dun sa ating phenoxide ion. So in that, ito yung mga resonance structures niya, wherein due to the movement or the stability of our benzene ring, pwede actually mag-move yung negative charge natin papunta ron sa ring itself. So, pwedeng mangyari, magkakaroon tayo ng double bond dito sa ating benzene ring, wherein pwedeng ma-abstract yung or pwedeng yung isang electron dito sa double bond natin ay pumunta rito sa oxygen, meaning magkakaroon tayo ng double bond. That means that we will have a negative charge in here, and we will still retain our double bonds here. So the same can happen if mag-move yung electron natin dito sa double bond na to, papunta dyan sa negative na yan. Therefore, magkakaroon tayo ng double bond dito. Nare-retain yung ating oxygen dito. And retained yung double bond na to. And we will have here our negative side here. And the same can happen para dito sa bond na to, wherein one of the electrons here will move to this bond, therefore forming a double bond here, retention of bond here, and our double bond to our oxygen. And uh, due to the existence of negative charge here, ganun lang ulit yung mangyayari. Pwedeng yung double bond dito ay mag-move, or one of the electrons here in our double bond will move to that electron here, babalik na dun sa resonance structure natin, wherein we will have the double bond here, double bond here, and the double bond here. And as you may notice, we actually had a movement of bonds from our phenol or our phenoxide. So this phenoxide ion actually has a tendency na gawing acidic yung ating phenoxide ion. And if we are to look for the relative acidity of phenol, if we are just considering our organic compound, one of the most acidic organic compound that we may have is our carboxylic acids. Next dyan are yung ating phenol or yung ating AROH. Next dyan sa acidity na yan ay yung ating water. Meaning to say, our phenoxide ion or our phenol is actually uh, are actually more acidic than our water. Next dyan ay sa ating acidity ay yung ating ROH or yung ating alcohol. Then we have there our alkyne, wherein we have there our terminal alkyne to be specific. And next dyan, syempre ito ay hindi na acidic, yung ating ammonia, and also our RH or yung ating mga alkenes. So that is the relative acidities of phenoxide. And as you may notice here, if we are considering just organic compounds, um, nasa medyo pangalawa, kasunod ng carboxylic acids yung ating phenols. And for those of you na hindi familiar sa mga carboxylic acid, one of the most common carboxylic acid that we have is our acetic acid, which is actually dissolved in water to form what we know we know as vinegar. And as you may have remembered, vinegar are actually acidic. So, why? Bakit? Uh, bakit kaya acidic yung ating phenoxide ion? This is due to the stability of the benzene ring itself. So, dahil dun sa pagiging stable ng ating benzene ring, kasi yung benzene ring na yan ay stable kasi due to that stability, the phenol or phenoxide ion has greater tendency to retain its ion form. And due to that retention of that ion form, uh, mas nagiging acidic siya. Okay? And talking about that acidity, that acidity is actually affected by the acidity, the substituents. So, paano mangyayari na nakaka-apekto yung substituents natin? As you may have remembered, due to the possibility of what we call electrophilic substitution, instead of just having our hydroxide ion or hydroxide group, that a hydroxyl group that is attached to our phenol, pwede rin tayong magkaroon pa ng iba pang substituents. And that substituents actually affect the acidity of phenol. By acidity of phenol, if we actually consider groups, let's say G, that are releasing, okay? So, yung tinatawag nating mga electron-releasing groups, meaning these are groups or substituents that has tendencies to give off or kumbaga, donate electrons to our phenol. What will happen here? It will actually have lesser acidity. This is actually less acidic in comparison to our just phenol. Okay? Why? Because due to the addition of electrons to our molecule here, hindi mare-retain yung tinatawag nating phenoxide ion or hindi magiging ganun ka-stable yung ating phenoxide ion because we have an electron donor and making the benzene ring and the OH neutral. So that is why uh, e- electron releasing group are less acidic. Electron releasing group that is a substituent of our phenol is actually less acidic. So, and in that, so kung meron tayong electron releasing, meron din tayong electron withdrawing or yung tinatawag nating G pag ganyan. So these are actually electron withdrawing groups. So these are groups of atoms or what we call molecules or groups that has a tendency to retain or to receive electrons from the benzene ring. And due to that, mas mare-retain yung ating yung ating negative charge or mas mare-retain yung pagiging phenoxide ion ng ating phenol, therefore making this more acidic than our phenol. Okay? So in that is the effect of addition or the effects of substituents that is attached to our aromatic ring that can affect the acidity of our phenols. So ano ba yung mga sinasabi nating electron releasing group? Andyan yung ating mga R groups, yung ating alkane, alkyne, and alkene. So those can be electron releasing groups. Pwede rin dyan yung ating, kung maalala nyo, actually ito yung ilan dun sa mga meta directors natin or yung mga tinatawag nating mga deactivators natin. So, maaalala nyo pa yung ating EAS. So, ilan dun sa mga activators natin or deactivators natin ay yung ating cyano, yung ating carboxylic acid, and the like. And also, for the withdrawing groups, andyan yung ating NO2. Okay? NO2 can be an electron withdrawing groups. Also, yung ating amines. Amines can also be electron withdrawing groups, thus making the phenoxide or the phenol more acidic. Okay? So, our next reaction is the electrophilic aromatic substitution. So as you may have remembered, our OH group is actually is a strong activator of the benzene ring towards what we call electrophilic aromatic substitution. So that just means that it enables weak electrophiles to attack the ring. So meaning to say, if we have phenol, we may expect an ortho and para orientation of our other substituents. O kumbaga, kung mag-a-add tayo ng panibagong substituents dito sa ating dito sa ating phenol, there is a tendency that those electrophiles or weak electrophiles will actually bond at this ortho. Naalala niyo yung ortho and also our para side of our benzene ring. So, in reference to our hydroxyl part. So, kumbaga, if we are to add, let's say, kung maalala nyo last time, if we are to add, say, if we are to react this with our NO3, our nitric acid, and that has I think that is 100 degrees Celsius, we may expect that we will have products or majority of our products will actually have this formation wherein we will have here our NO3, okay? Also, and we may also have products that may have this structure wherein our NO3 is located at our para orientation. So those are the effects of, or that is electrophilic aromatic substitution involving phenol. Okay? And for the last reaction, we have here oxidation. For oxidation, bearing tertiary carbon atoms in benzene ring, oxidation of phenol is possible. Actually, if we have, ideally, for the reaction of phenol, if we have an oxidizing agent, say we have their RO, this will actually favor the formation of what we call a para-benzoquinone. So ano ba yung itsura ng tinatawag nating para-benzoquinone? So, or specific, to be precise, mangyayari, we have here our benzene ring. Then, in that benzene ring, ano mangyayari? Due to the addition of that oxygen, matatanggal actually yung double bonds na yan, and they will be oriented this way. We will have a double bond about our oxygen atom, and we will have another oxygen to carbon double bond at the para direction of our phenol. So meaning to say, we will have here what we call a para benzoquinone, or you can just write quinone kung ano, kung nalilito kayo. Pero there are other types of quinone, kaya isinulat ko ito ng ganito. And upon adding or allowing the parabenzene quinone to oxidize further, we will have here this compound where we call this compound as our maleic acid. So as you can see here, nagkaroon tayo ng quinone or ketone pala. Then we have here our carboxylic acid. So one of the examples of oxidation that we may encounter in the field is actually the the reaction of what we call hydroquinone. So as you can see here, we have here a hydroquinone. If that hydroquinone is actually oxidized using our sodium chromate with the presence of selenium chloride and water, we will actually also produce what we call our paraquinone. Okay? So, pero ang kaibahan dito ng oxidation na to, in comparison with our aforementioned oxidation, this reaction is actually reversible. So, kumbaga, there will be a backward and a forward reaction for this one. Wherein, yan, makakaproduce ulit tayo ng tinatawag nating para benzoquinone. Okay? And for the last part, if we have this one, wherein we have here a 1,2 hydroxy dihydroxybenzene, and we repeat that formula or yung ginamit natin kanina, wherein we added this reagent, Cr2O7 and our selenium chloride and H2O. What will happen here is we will actually produce another type of quinone, wherein we will have here this quinone called the ortho benzoquinone. Okay, so those are the examples of our oxidation reaction. Pero remind ko lang din, this reaction is also reversible. We have a forward and backward reaction here. So this is our oxidation. Okay, in that will be all for today or for now. So next time we will be discussing ethers. So, in that, have a good one. Bye bye.